Hello again, everybody, and welcome back. I decided to recently take a bit of a break from circuits and hardware and embedded software and do some desktop software. Specifically, let's work with OpenCV a little bit. So in this first OpenCV tutorial, we're going to cover a quick and easy, down and dirty way to perform object recognition and motion tracking. So what we're going to do is we're going to write a program that will identify and track a ball of a solid color, more or less. It doesn't have to be a perfectly solid color. For example, if you have a tennis ball, it's going to be mostly yellow and then it has those white lines weaved around it, that'll be fine. Or if you have a basketball that's mostly orange and then has black or white lines weaved around it, that'll work fine too. Really basically anything that's a circular shape and mostly a solid color. In my case, I bought 3 foam kind of playground type balls from Walmart that were I think 50 cents each. Anything like that would be fine. So what we're going to do is we're going to cover OpenCV installation and configuration with Microsoft Visual C++ 2010, and then of course also writing the program. This program really isn't going to be that elaborate or complicated. Even with lots of comments and spacing, it's still going to be under 150 lines. And we're going to use the precompiled OpenCV binaries, specifically version 2.2. Later on, I'll probably do a tutorial on covering how to compile OpenCV from source, which you definitely want to do because that way you can use different versions, different operating systems, etc. as you prefer. But just to get started, let's use the precompiled binaries to make it as easy as possible. The hardware I'll be using for this demonstration is not high-end hardware at all. You really don't need high-end hardware to make OpenCV work really well for you. The webcam I'm using is a Logitech Pro 9000. I got it, I think, about 2 years ago on Amazon.com. I think it's about $60 currently. Let's take a quick look at that. Where's my Amazon.com link? There we go. Logitech Pro 9000. So here we go, 61 bucks. This is a pretty good webcam. It has this Carl Zeiss optics feature. Personally, I like Logitech webcams most. You see Amazon.com, it's the same price, 61 bucks. They do have a newer model out. It's probably on here. Here we go, Logitech HD Pro webcam C920, full 1080p. So this is a step better, a newer webcam, 81 bucks. Either of these would be fine though. Basically, what you really don't want to do is don't use a super cheap one. If you have like a $20 webcam or one that's 10 years old that's only, say, 320 by 240 resolution, that probably won't work that well. Get at least a mid-level webcam, but you don't need some super fancy professional $5,000 thing. Just this kind of run-of-the-mill mid-level $60 off-the-shelf one would be just fine. And then the computer I'm using is a $300 2-year-old economy computer I got from Best Buy. Here's the specs for those of you with the hardware stuff. AMD Athlon processor. It's really a very low-end computer. You don't need a fancy computer at all. Any computer you bought in the last 5 years even would probably be just fine for what we're going to do today. So before we go any further, let's take a look at the program that we'll have when we're done, and then we'll go from there. So here's what we'll have when we're done, is this executable here. Currently I call this one tracker6.exe. I did a bunch of different versions to prepare for this video, but here's the latest one, and I'll write 7. Probably during this video. But anyhow, it's going to open up 2 windows. So here's the current webcam view of my apartment. There I am waving. And then this is the image that I'm calling the processed image, I guess, for lack of a better term. And what the processed image is everything within a certain color range in the image from the webcam, what I'm calling the original image. And the processed image will appear as white. And everything else will appear as black. And then we're going to call a function that's going to go through the processed image and pick out any circles in it. And then with that circle information, we're going to draw a red circle around the ball that we've located, and then a green dot at the center point of it. And then in the command line window here, we're going to print the X and Y coordinates of the center point of the circle and also the radius of it. So let's take a quick look at that working. And as you can see, it tracks the ball pretty quick. It's not perfect. I've done this wearing a red shirt, for example, and it really can't tell a red shirt from the ball. This is a pretty basic algorithm, but as you can see, it works pretty fast, and it works is the bottom line. It's a quick and easy way to do it. All right, so next, let's take a look at installing Microsoft Visual C++ and OpenCV 2.2. Before we get into installing Visual Studio and Microsoft Visual C++, if you haven't done those already, I want to make sure to give credit where credit is due here. Most of the code for this tutorial we're going to go through today is really from this site here, www.lurtex.com. This is the original author. So here he's showing how to track an orange ball, some various screenshots and code involved in the algorithm. And here's his YouTube video. And then here's the code in Python, including servo motor movement. And then here's the C++ source. So this is really the original author, Lior Chen. And I really took that program and it's his originally and just sort of made it a little bit more readable, I guess, a little bit easier to follow, a little bit simpler, so that it's good for a first tutorial. But definitely, if you're interested, check out this site. He's got lots of other neat stuff on here too. Some stuff with microcontrollers. The rest of this robot that the fast motion tracking goes into. He's got some cell phone stuff, some Linux stuff. So definitely check out www.lurtex.com. One more thing I should mention before we really get started in earnest here is some of the resources that you can use to learn about OpenCV, because of course this is just a beginning tutorial video. I'm sure you'll have lots of questions and things will come up. This is the main OpenCV site here, the Willow Garage site, and there's a documentation. A lot is online, and also there's two books in particular that I definitely would recommend. There's Learning OpenCV and then OpenCV 2, Computer Vision Application Programming Cookbook. This OpenCV is this is an excellent book. It's a little bit aged now. It was, I believe, written in 2007 and copyrighted in 2008. So it's based on OpenCV 1, and we're now moving into OpenCV 2. But this book is really still a great resource. Lots of stuff on the algorithms and how it works, OpenCV internals. Definitely a very good read. Also, this book here is a newer book. This book doesn't get into theory quite as much. It's more of kind of a cookbook. This is how you can make it do X. And then it quickly and easily shows you how. So definitely, both these books are references you're going to want to have around, in addition to the Willow Garage site documentation, as you learn OpenCV more over time. Is the software that we'll be using today. So the first thing we're going to do, if you don't have Microsoft Visual C++ 2010 installed on your computer, you're definitely going to want to get that now. And we can use the Express edition, the free one. That's perfectly fine. So you can pretty easily find the link from searching. Go ahead and download this and install it. It's already installed on my computer. I'm not going to go through the screens. Basically, just choose all the defaults. It should install fine. It's pretty rare that there's a problem with the install of Visual Studio. In fact, I've been installing Visual Studio for a number of years on different computers. I've never had a problem installing it, so that should go just fine for you. Then what you're going to need to do after that is get the OpenCV install. So if we go back to the Willow Garage page and then downloads, and then OpenCV Win, you'll see the different versions. Most current version is 2.4.0, 2.3.1, and then eventually we're going to get back to 2.2, which we're going to use today. Something I should show you here is that not all versions have precompiled binaries, and the precompiled binaries only work with certain operating systems and compilers. For example, the one we're going to use today is OpenCV 2.2.0, Windows 32, Visual Studio 2010. So for example, if you were using Visual Studio 2008, this might not work. If you're using the 2012 or 2013 Visual Studio Beta, whenever the next version is that comes out, this might not work. If you're not using, well, this should work with any version of Windows. I know it works with Windows 7, either 32-bit or 64-bit computer, even though it's a 32-bit version. But if you're using a different, say you're using, probably nobody's using XP anymore, say you're using Vista, I haven't tested it on that, it might not work. Really, the best way to work with Visual Studio, with OpenCV rather, is to compile from source. And if you were going to do that, what you would do is download the zip of the source and then compile it yourself. The other reason that that's advantageous is because for this year here, 2.2.0, for this version rather, I should say, there is a precompiled executable for the particular operating system compiler, etc., that we're going to be using today. But that might not always be the case. For example, 2.3, I believe, doesn't have one. well, it has a Win Super Pack, but I don't believe that actually includes an executable. There's the source, and then there's the GPU support. So if you wanted to use version 2.3, but you didn't know how to compile from source, you'd be out of luck. I believe in 2.4 they added the precompiled binary back, Win Super Pack. But in any case, you get the idea. You're really limiting yourself if you can't compile from source eventually. So in a future video, I'm going to cover that. It looks like they did add the precompiled binary for 2.4.0. But for now, rather than worrying about compiling from source, we're just going to stick with this OpenCV 2.2.0 Windows 32 Visual Studio 2010.exe precompiled binary. And if you're using a different operating system yourself or a different compiler, I don't know what to say other than I guess you're going to have to wait for the next video where I show how to compile from source. So we're going to download the file. It's not especially large. And we'll choose to save it. And there is one option. I want to go through the install here because there's one option that you have to make sure to choose. Otherwise, Visual Studio won't be able to see the OpenCV install. We'll get to that in just a moment. Okay, let's put it in downloads. That sounds good. That already exists. You want to replace it? Sure. Of course, I downloaded it before. I uninstalled it before this. So at this point, I'm probably going to pause the video and fast forward it. Alrighty, so now the download's complete, and here we are, OpenCV 2.2.0 Win32 Visual Studio 2010 EXE. Yes, we want to allow it, of course. Next, we agree. This option here is important. Either you could do this manually later, but it's easier to do it during the install. You definitely want to choose Add OpenCV to the system path for all users. If you don't do this and you also don't do it manually later, what you're going to have to do is there's a few OpenCV DLLs that you would have to copy into each Visual Studio project that you did. The alternative way, the better way, is to simply add OpenCV to the path for all users, and then you don't have to worry about that. That is something to keep in mind. In the event that you were ever to distribute your program, you'd either have to have the installer on the programs it's being installed on the computers it's being installed on, rather, would have to add OpenCV to the path, or else you'd have to copy those DLLs with your distribution. So from here, we can pretty much choose all the defaults. No reason not to do the full main and source, and install. Okay, so a quick follow-up here. After the uninstall finished, I rebooted, so then if we type path at the command prompt towards the bottom, I believe, and there it is, C:\OpenCV 2.2 bin. If when you did the install you didn't happen to do that, or later on when you're compiling from source, there isn't an installer to do it for you automatically. Just for those that aren't familiar with how to add something to your path in Windows 7, if you go to Control Panel, System, I must be looking right by it, there it is, Advanced System Settings, and similar in other Windows operating system versions. So then if you go down here to Environment Variables, and then Path, you can choose Edit, and then Add it. You put a semicolon at the end, and then you put the path in that you're looking to add. Alternatively, you could go to C:\OpenCV 2.2 bin. And you could copy the applicable DLLs that you need from here into your program, but that is the same directory as your Visual Studio project. But as you can see, there's quite a few of them. It's really better to just add the path variable. So here we are in Visual Studio 2010, specifically Visual C++ 2010 Express. You can configure the icons and so on as you prefer. One thing that I should mention now, though, is that I'm going to be referring to this Property Manager tab later. If this isn't appearing in your install and you just installed Visual C++ 2010, probably what you need to do is go to Tools, Settings, and by default, this is on Basic Settings, as I recall. You definitely want to put this to Expert Settings. That's going to unhide a lot of stuff that you need to see. If after doing that, Property Manager still isn't viewable at the bottom, you can always go to View and then Property Manager. Alrighty, so now we're ready to create our project in Visual C++ 2010 Express, and also to configure our project so that it can see our Visual Studio, or our OpenCV rather, installed. So how we're going to do that is we're going to go to File, New Project, or press this icon, and let's call our project, I'll call it Tracker 7, and create a directory for the solution is checked. That's good. Usual location. Definitely want to choose Win32 console application. And then choose Next. Uncheck precompiled header. We don't want it to write any code for us. And choose Empty Project. And then make sure you have the console application radio button chosen. And then Finish. So then if we go to Solution Explorer, right-click on the, or left-click rather, on the project, then right-click on it, and go to Add New Item, C++ file, and we might as well call it the same name as the project and the solution. Keep everything simple, Tracker 7. And there's our nice C++ file. Put a comment at the top of it. Tracker7.cpp. And now the next thing we're going to need to do is we're going to need to add a property sheet to the property manager here so that our project can see the necessary part of the OpenCV install. So how we're going to do that is you want to choose either debug or release. And to make everything as easy as possible and be as consistent as possible, we'll just leave it as the default debug within Visual C++ 2010 Express. So we'll choose the debug folder here, then right-click on that, go to Add New Project Property Sheet. Now the good thing about these property sheets is once you make them, you can copy them into your next projects, so you really only have to make it once as long as your OpenCV install doesn't change. So we'll call it my OpenCV prop sheet. And then Add. And then it appears over here, so now we're going to click on that, and then right-click on that, go to Properties. And there's three places here that we have to tell our property sheet about our OpenCV install. So under Common Properties, we're going to go to Visual C++ Directories, and then Include Directories, and Edit. And then we're going to add New, C:\\, and here we're going to choose OpenCV 2.2 Include. Which makes sense, of course, because that was the include directory. Now, under the library directories, we're going to do the same thing, edit, new, and then, not surprisingly, we're going to do OpenCV 2.2 lib. Now, there's one more area we need to add some more information here. Before we're under Common Properties, Visual C++ Directories, now we're going to go under Linker, expand it, and then go to Input. And then Additional Dependencies is the first option at the top. Now what we're going to need to do here is we're going to need to add a number of library files, specific library files I should say. So if we go to C OpenCV 2.2 lib, here's all these library files, and these are essentially the functionality of OpenCV broken down into kind of its different parts. So for each of them, there's the regular version. So for example, OpenCV Calib 3D, Calibrate 3D. The 2.2.0 that's the 2.2.0 version of OpenCV. And then the next file is the same thing, but with the D at the end. Now the D is for debug, and we're using the debug version. So what we're going to want to do is into this additional dependencies box here, we're going to want to type OpenCV Calib 3D 220D, and then all the other ones that end in a D also. So contrib D, core 220D, features 220D, ffmpeg 220D, and so on, all the way down the list. You could pick and choose which one of these you want to install that you're going to use for one particular project, but frankly, I think it's easier to just include them all. That way you know whichever functions you're calling are included, and then you can use the same property sheet from one project to the next. Then we'll choose Apply and OK. And now our project, our Visual C++ 2010 Express project, is fully configured to see our OpenCV install. So before we actually start writing code, let's take a quick look at some of the structures and functions we're going to use in our program. So in this tutorial, we're going to use OpenCV1 structures and functions. Probably in a future tutorial, maybe the next one, I'll get into the OpenCV2 structures and functions. But for now, to get started, let's stick with OpenCV1. So here are the structures, and again, OpenCV1 was written in C, so there actually are no objects. I might slip up and call these objects on occasion by accident, but in fact, since it's really C, they're all structures. So what we're going to use here is CV size. That's the size of the image to be used. By the way, you definitely want to have your webcam set at 640 by 480 pixels because that's what we're going to use for both the image we're capturing and the processed image. And if this is different than your webcam setting, it might cause a problem. So then after that, we're going to use the CV capture object. This is the object that captures our webcam stream of images. In other words, it associates a webcam to this structure in our program. And then we're going to have an IPL image structure, actually two of them, which is it's really a pointer to an image. And this is what's used for all images with OpenCV1 functions. And we're also going to have a CV mem storage structure. There's one particular function that you have to feed this into it, otherwise it won't do what it needs to. We'll get to that in more detail later. And then a CV sequential object. And what this is it's a sequence. In other words, it's kind of similar to a linked list in C, or in the standard template C++ library, what a container is, the way you can step through it. It's sort of like the OpenCV version of that. And what this is going to be is it's going to be the series of circles that are found in our image. And then this last one here is actually a function, not a structure, but there's no structure to call first, so I just listed the function as CV named window. This is what you do to actually draw a window on the screen. I should mention that even though we're using an OpenCV2 install, specifically version 2.2.0, you can still call OpenCV1 functions without a problem. It's pretty much fully backwards compatible. So those are the structures. Let's take a look at some of the functions that we're going to call. So this first set of functions here is this is to do kind of setup-oriented stuff. CV capture from cam. This associates the capture structure to our webcam, and then we're going to call named window. This declares a window. Note it doesn't automatically show it. And then we're going to call create image. This creates a blank image, and then we're going to fill the processed image into that later on. And then query frame gets a single frame from the webcam. So we're going to have a loop that calls query frame at the beginning of each time, and then we're going to process that image. So here's the functions that are actually going to do the processing. So we have CV in range S. What this does is it takes an input and an output image, which are passed by reference. It actually has 4 parameters, and the input image is the first parameter, the output image is the fourth. The 2 in the middle are CV scalar structures. We don't really have to know the details of that, though, because we can use the CV RGB macro to simplify the function call. And what we're going to do is we're going to enter the RGB values for filtering. So we're going to enter the minimum value and then the maximum value. So for each pixel in the image, if the output image at the same pixel location will be set to white if the pixel in the original image is within the minimum and maximum color value range that we specify, and it will be set to black in the output image if it's not. This way the output image will be white around the object of interest and then black everywhere else, and then we can look for circles in the image after that. Then next we're going to call CV smooth. This is a good idea when you're trying to identify objects. Inevitably, when you have an actual picture, the edges and everything aren't perfect, so you want to blur them a little bit. That makes the next function that's going to pick out the circles work a little bit better. And the next function is CV hue circles. This is a function that actually locates the circles in the processed image and returns a pointer to a CV sequential structure that is a list of the circles found. So the next we're going to call CV get sequential elements. And what this does is it gets from the CV sequential structure, it pulls only one of those sets of information, I guess you could say, or one of the circles in this case is what the information represents. And an index is passed in. So this works just like how, if you think of an array index, you can have 0, 1, 2, etc. It's the same idea. And what this function is going to do is it's going to return a pointer to a float, which is going to, since this is in essence really see. So that's the same thing as a float array. And it's going to have three elements: the circle center point location in both the x and y coordinates, and then also the circle radius. And then once we have that, we're going to call CV circle. We're actually going to call this twice. This function draws a circle on an image. So the first time we're going to draw a 3-pixel radius green circle at the center point of the object, and then the second time we'll draw a red circle around the object. This might not seem especially clear at this point, but hopefully as we get into the code, things will kind of clarify themselves as we go. And then also at the end, we're going to do some memory deallocation, but we'll get to that at the end of the program. Let's get started. Alrighty, now we can get back to Visual Studio and start coding. So first we're going to do our includes. We're going to have 5 of them. We'll need CV aux. And also high GUI, CV high GUI. This is the function that allows you to draw windows and so on. There we go. It wasn't done parsing the files in the OpenCV install there for a moment. And you'll notice the autocomplete here does detect the files because, of course, it can see them since we set it up that way. And now we'll do 2 regular C includes. I'm sure you'll recognize these. Standard I/O. And standard live.h. Now we're ready for function main. Since this is going to be a pretty small program, we'll just do the whole thing in one function. We don't really need any function calls. And argc. Character argv. Okay, so now we're going to get to that CV size object. So CV size, and let's call it, I like to use an abbreviation in my variables as to what structure type it is. I kind of picked that up as a habit from Visual Basic 6. Some people just find that gets in the way. I find it helpful myself. We'll just abbreviate size with size since it's only 4 letters anyhow. So this takes 2 parameters, 640 and 480. So we're going to use a 640 by 480 size for all windows. Also make sure your webcam is set to 640 by 480. All right, next we're going to have the CV capture object. And that's a pointer to a CV capture. And we'll worry about initializing that later. And next we're going to have our 2 image objects. And so we'll abbreviate image img. This will be the input image from the webcam. Then we're going to do IPL image p_image processed That'll be the black and white image. I'm kind of over commenting this, because this is really a tutorial. If you're actually writing a working program just, to get it done, of course you wouldn't put this many comments in it. In case you're interested, IPL is short for Intel Image Processing Library. This is the standard structure used in OpenCV. One to work with images. So next we're going to declare the CV mem storage structure. So this is necessary storage variable to pass into CV hue circles, and more on that later. Now we're going to have that sequential structure. I'll abbreviate that SEQ, and let's call it circles, since it's essentially going to store a series of circles. This is a pointer to an open CV sequence will be returned by CV hue circles. And will contain all circles. Okay, so the next variable, actually we should probably also note that calling CV get sequential element and then you pass in the pointer to the sequential object, and then the index is I, so that will return a 3-element array of the ith circle. See next variable. So here's that next variable, pointer to a float, which of course is the same thing as a float array. So this is going to be, I'll call it XY radius. So the 0th element, or 0 index, will be the x position of the detected object. And the 1 will be the y position of the detected object. And the 2 will be the radius of the detected object. Okay, just a few more variables here. Int I, this of course is a loop counter. free up some screen space here. And then we're going to need a character to check for an escape key press to jump out of the loop that otherwise would be infinite. Alrighty, now we're ready to get our capture from our camera. So pcap webcam. It's going to be assigned the function CV capture from cam and 0. So if you have only one webcam installed, that's going to be webcam 0. If you have two, one will be 0 and one will be 1 and so on. So if you have multiple webcams, you might have to put something other than 0 to get the webcam you'd prefer, but if you only have one installed, this will work fine. Alright, so next we're going to put a quick conditional statement to check and make sure that the capture process was successful. So for example, if the webcam wasn't plugged in, we'd want to exit the program. Error capture is null. So I'm going to call getCharacter to pause for the user to see the message. And then we'll return. Alright, so now we're sure we have a good string. So we're going to declare our two windows. And how we do that is with the CV, OpenCV function CV named window. And we'll make the names correspond to the names of the images up here, original and processed. And then we'll put the second parameter CV window auto size. Since the images are 640 by 480, then calling auto size will make the windows the correct size. Can't type all of a sudden here. Second one processed, and then CV window auto size. So this will be the processed image we will use for detecting circles. Now, since we're going to get the original image from the webcam, we need to declare the processed image. So we'll do that next. P_image process is assigned CV create image. So now we're going to pass in that size object we declared earlier, or size structure rather. Alright, second parameter is going to be IPL depth, 8U. And what that's short for is 8 bits unsigned. So in other words, if this was a grayscale image, which is it's going to be, each pixel could go from 0 to 255 grayscale. If you were doing the same function but with a color image, then you'd have a red, a green, and a blue value for each pixel. They could go from 0 to 255 since it's 8-bit unsigned. So this we call the depth, 8-bit color depth. And then the last parameter is going to be, you're pretty much always going to make that 1 if it's grayscale, which this image is, because remember we want what we're trying to track to be white and then the background to be black, so we can pick out the circles as easily as possible. So this is one channel, grayscale. So just for your future reference, if this was a color image, then you would use 3 here. Alright, so now that our setup stuff's done, we're ready to enter our infinite while loop where the frame is grabbed from webcam and processed. So while 1, and we'll use an escape key press to jump out of the loop when the escape key is actually pressed. We'll get to that at the end though. So for each frame, we're going to get the frame, so p underscore image original is going to be assigned CV query frame. And then we need to list the capture object here. Okay, now we're going to need a conditional statement to make sure that that frame capture actually was successful. If not, we probably need to exit. We're going to print that to standard out. And then get character again to pause so the user can see it. And then we're going to break. Alrighty, now we're sure we have our image and we're ready to actually start the processing of it. So here's where we're going to call CV in range S. So there's 4 parameters here. Image original. So this essentially is the function input. Now we're going to use this macro CV RGB. And what this does is it actually creates a CV scalar object, which can take up to 4 parameters, but the thing is we don't need to use the fourth, we just need the first 3, red, green, and blue. So we'll use the CV RGB macro to make life easy on ourselves. So the first RGB, in other words, the second parameter to the function, you're going to pass in the minimum RG and B values, and we're trying to detect a red ball, so we're going to need the red to be at least 175, and then the green and blue can be 0. And again, if you have a different color ball, you'll need to adjust these values applicably for the ball that you have. So minimum filtering value. And that's inclusive greater than or equal to. Then the next line is going to be CV RGB 256 because this is not inclusive. So in other words, we want it to go up to 255 red. And it could have, if you have something that's pink, for example, that could be like 255, 100, 100. That'll basically more or less be a shade of pink. So in that case, what we're going to want to do is we're going to allow up to 100 green and 100 blue. And we want to make sure we get everything that's either red or darn close to red. And that'll be the max filtering value. And the last parameter is the output, and it's passed by reference. So this function doesn't actually return anything. It's the fourth parameter is the output. So image processed. So at this point, image process will be a black and white image. The ball we're trying to track will be white, and everything else should be black, ideally. So next we're going to have to allocate the storage variable. We're going to need this to pass into CV hue circles momentarily. So the next thing we're going to do is we're going to apply a Gaussian smoothing to the processed image. So we're going to call CV smooth. And the first parameter is the input to the function. Actually, we should probably comment that first. Smooth the processed image. This will make it easier. For the next function to pick out the circles. By the way, I probably should have mentioned in range S. Of course, the input image is a color image, and the output image is a black and white image. So as of this point forward, image processed is black and white. So that'll be our function input. And also our function output. So again, this is passed by reference. The function doesn't actually return anything. And then we're going to choose for the third parameter, CV Gaussian. So we're going to use a Gaussian filter. So what the Gaussian filter does is it averages the nearby pixels with the closest pixels weighted more. And I'll explain that a little bit more in a moment. Then the next two parameters are the filter window, or sometimes it's called the filter aperture. And we're going to choose 9 and 9. So, in other words, let's comment that first. So that's the smoothing filter window width. And the smoothing filter window height. So, in other words, what this function is going to do is if you imagine a 9 by 9 box of pixels in the original image, and I don't mean original images from the webcam, I mean the input image. So in other words, it's going to copy the image that we're passing in. And for each pixel in the image, it's going to look at all the pixels around it in a 9 by 9 box. And in the output image, so that's the second parameter, it's going to average those pixels in that 9 by 9 box and apply that average to the pixel that it's on currently. So what that's going to do is it's overall going to smooth the image out. Now the Gaussian filter specifically, it weights in its averaging process the pixels closest to the center pixel more and the pixels to the outside less, and that produces a better smoothing effect than if you were to average all of a 9 by 9 pixel window to the center pixel. If you'd like more information on this, check the internet, Gaussian filter, Gaussian blur, Gaussian smoothing, anything like that. There's a lot out there on it. So the next function is we're finally ready to call the CV hue circles function. And this is the function that's actually going to go through our black and white image and select all the circles. So the first parameter is going to be the processed image that we just smoothed. Let's comment that too. So what this function does is it fills a sequential structure with all circles in the processed image. So the first parameter is the input image. Note that this has to be grayscale. No color. And the second parameter is going to be that storage object. And the only reason we declared that earlier is to pass it in as the second parameter here. The function requires the storage object for storage. We don't really need to worry about the details why. And also, if you pass this parameter in as a storage structure, it will make the function return a pointer to a CV sequential object, or structure rather. Alright, so the next object is going to be, we're going to pass in CV hue gradient, which actually is the only possibility for the third parameter. And what this is it's a two-pass algorithm for detecting circles. That's the only choice available for this parameter. And then next we're going to pass in a 2. And this is the size of the image divided by this value gives you what we call accumulator resolution. So in other words, accumulator resolution equals the size of the image divided by 2. Our next parameter is going to be the height of the processed image divided by 4. And what that is that's the minimum distance in pixels between the centers of the detected circles. So for example, the height of our image is 480 pixels, so if we're doing 480 divided by 4 is 120, so in other words, this function will not return 2 circles that are within 120 pixels of each other at the center points. And the reason for that is if you only had one object in the picture and say the lighting wasn't perfect or something to that effect, you could end up with that one object detected 3 times when there's only one there. So having this parameter be a significant number of pixels prevents multiple detections of one object. And now the next 4 parameters are all numbers. 150, 10, and 400. And what those are is the 100 is the high threshold of the canny edge detector, which is actually called by the CV hue circles function. And then the 50 is going to be the low threshold of the canny edge detector. As a general rule of thumb, you want to make the low threshold half of the high. And the higher you make the number, the more selective the algorithm will be. So it'll have to really and truly be a perfect circle of exactly the color you're looking for. If you made it a lower number, it would pick up objects more easily, but then you'd also have more false detections. So then the 10, that's going to be the minimum circle radius, and then the 400 is going to be the maximum circle radius, again in pixels. So again, depending on how large your webcam is set to, in our case everything's 640 by 480. If you had a bigger or smaller image, if you're trying to track a larger or smaller object, you would maybe need to change these to fit. But this way at least anything that's too extreme, like something really small in the background that's less than 10 pixels in radius, isn't going to be picked up as a circle, and something that's enormous that takes up the whole image isn't going to be detected as a circle, so it won't obstruct the other objects from actually being detected. Alrighty, so now we've got this CV sequential object. So what we're going to do is we're going to step through that. Now, if there's only one ball in the picture, just notice I had a typo up here. If there's only one ball in the picture, then this next for loop is only going to run once. If there's, it's going to run as many times as there are objects that have been detected, though. So we're going to run while start I out at 0, and run while I is less than p sequential circles. So this is for each element in the sequential circle structure. In other words, for each object detected. Okay, so what we're going to do is we're going to assign to this variable float xy radius. The result of a function called CV get sequential element. And we're going to use the ith element in sequential circles. All right, now that we have that, we can show the value on the screen. So xy and radius. So that's going to be our float pointer. So that's going to be the x position of the circle, of the center point of the circle. And then element 1 will be the y position of the center point of the circle. And then element 2 will be the radius of the center point of the circle, or radius of the circle, rather. And again, that's in pixels. Okay, so now we're ready to draw our two circles onto our original image. So the first one's going to be a small green 3-pixel radius circle at the center point of the object we've detected. And then the second circle we're going to draw is going to be a red circle around the outside of the object. So we're going to call CV circle for that. First parameter is going to be the original image. since that's what we're drawing on. And the next parameter is going to be the center point of the circle, so for that we can call CV point. So float xy radius 0 again is the x center point. And then 3. So this is the 3 pixel radius of circle. And the next parameter is going to be the color. So we'll make that pure green. Again, we'll use the CV RGB macro to make life easy on ourselves. And then we're going to put CV filled, and that will fill in the circle. So this is the thickness parameter. In this case, we're going to fill in the circle. Let's neaten up our spacing a little bit. Okay, so now we're going to draw a red circle around the detected object. Once again, we're going to draw on the original image. And then we're going to call CV point to pass in the x and y coordinates. This is going to be exactly the same as in the previous function call, so I'll simply copy and paste it. Now for the radius, we're going to call CV round. Float xy radius, and element 2, the third element, will be the radius. And now we're going to pass in the color. We'll draw pure red. And then we're going to pass in the thickness of the circle in pixels. This time we don't want to fill it in, we just want to draw it around the edge. So 3 pixel thickness should be good. And that's going to end our for loop. almost there. At this point, basically, we just have to show the images that we've already generated. So CV show image. Original. This can be the original image with the ball circles overlay. And then the processed image. Then we have to release that memory storage variable that we had to pass into CV hue circles earlier. And now we're going to check for the escape key. That's the only way to break out of the infinite while loop. So we'll call CV wait key 10. That's the wait for 10 milliseconds. And then I'll get the key press if there is one. And then if that key is 27, then we're going to break. So in other words, if the escape key, which is ASCII 27, was pressed, and jump out of the while loop. And that ends the while loop. And now we have a little bit of memory releasing to do. It's a good idea to do this with OpenCV 1. Fortunately, with OpenCV 2, where it's more object-oriented, you don't have to manage memory quite as directly, so this wouldn't be necessary, but in OpenCV 1 it still is. We're going to release our capture object. And then we're going to destroy our two windows. The operating system really would do these steps for you. You don't actually have to do this, but if you ever get into a situation where you're making multiple layers of function calls and you allocate and then deallocate and you get your pointers mixed up, that can cause problems. So it's a good habit to kind of note which memory you allocate at the beginning of the program and then deallocate it at the end. And then good old return 0. And that does it. Alrighty, so let's cross our fingers time here and compile it. See if I made any mistakes. I have a rebuild solution as a shortcut on the toolbar. If you don't have that though, you can go to build. I always go to rebuild just to make sure it's a clean build. And it might take a moment to compile. Again, this is an older computer, and hey, how about that? First go, succeeded. And let's run it. I put the start without debugging here on my toolbar again. If you don't have it there, You can always go to debug and then start without debugging. And there's our same windows as before. And there we go. How's that for a winner? Works great. So there you have it. Crash course in object recognition and motion tracking in OpenCV. Congratulations! You now know how to install and configure OpenCV for use with Microsoft Visual C++ 2010, and also how to perform basic object recognition and motion tracking with OpenCV. I'm going to post the code from this tutorial to my website, www.18f4550.com, if you prefer to download it rather than typing it in. And also, I've got some more OpenCV tutorial video ideas in mind. Probably I'm going to redo the same program, but using the OpenCV 2 functions, which are written in C++ and much more object-oriented and more of a modern design. And also, after that, I'm planning on doing an OpenCV video on how to compile from source, so that you're not limited to a certain compiler or operating system, etc. After that, I plan on doing an OpenCV tutorial with mgoocv, and what that is it's a set of wrapper functions written in .NET that allow you to call OpenCV function calls from within .NET. So for example, you could use C# to make your front end, Windows form, buttons, checkboxes, all that nice fancy stuff, and then you can still call OpenCV function calls from there. Also, Qt is a competitor to Visual Studio. It's another environment for those of you not familiar with it. And Qt is really excellent, and it's actually in C++ directly, so there's not as much of a translation as there would be in the case of .NET. So I think also in the future I'm going to do a OpenCV tutorial on how to use Qt to make OpenCV function calls, and then of course you have the environment to make your nice front end also. Eventually, I'd like to do a project where I would integrate OpenCV vision and hardware via USB, in other words motor control or something similar. So for example, you could have a camera mounted on servos, and then it would pan the camera around, the motors would rather pan the camera around the room to track an object as it moved. So that would be a combination of hardware, software interfacing, and then also OpenCV. But that's more of a long-term thing. I'm not sure which of these I'll do next, but definitely keep an eye out on my website, www.18f4550.com, and my YouTube channel, 18f4550 videos, for future content. And see everybody next time.